at the very last section, it's going to be covered on this test, inverse trig functions. And again, this is going to be based on your unit circle. Let me pull a unit circle in here real quick. Here we go. So this goes back to the unit circle, and make sure you have your unit circle completed correctly. Pretty important. All right, the inverse sine of -1/2. Remember, that's the same thing as saying, okay, sine of what angle is -1/2. And what you have to remember with inverse trig, you have to know your restrictions. And I gave these to you in another lesson, but your inverse sine, you have to look on the right side of the circle. You only give the answer that's on the right side of the circle. So I need to find where sine is -1/2. That's the y-coordinate. So I'm looking for a y-coordinate of -1/2. Well, if my y's are negative, I have to be looking down here, and it happens at this angle. Now, there is also a y-coordinate of -1/2 over here, but remember, you only answer on the right side of the circle, so we don't care about that left piece, that left side. Okay, then thing you have to remember, number 2, you may be thinking, okay, the angle is 330 degrees, or if you wanted to answer in radians, 11 pi over 6, you have to be comfortable with both, because these are potential multiple choice questions, and I may give you the radian answer in multiple choice. The problem with saying 330 or 11 pi over 6, if you remember, I told you that when you are answering inverse trig questions and you are going into the fourth quadrant, you always go the short distance. So if this is 0 degrees, if I want to get to 11 pi over 6, the quickest way would be for me to go backwards so many degrees. If you say 330 degrees, what that means is you actually opened up and you went all the way around to 90, to 180, to 270, keeping on, and finally we get to 330. We don't go the long way. We need to go the short way. So we will take that angle and we'll go, starting at 0, we'll just go backwards, and we actually go backwards 30 degrees. So that distance right there is a distance backwards 30 degrees. So we don't answer with 330. We would answer with -30 degrees, or instead of 11 pi over 6, we are going backwards pi over 6. That's one of the tricky parts of inverse trig, is knowing your restriction and then remembering that if you have an answer in the fourth quadrant, you have to give the negative angle. You don't go the long way around. So keep that in mind when you're answering these questions. And let's see, number 34. Tangent is, inverse tangent is one of my least favorite ones because it's not as easy. Let's see, inverse tangent, again, the restriction for tangent is the same as the restriction for inverse sine. We're going to look on the right side of the circle, and I need tangent to be positive √3 over 3. So I need tangent of some angle to be positive √3 over 3. Tangent's going to be positive in the first quadrant because you are dividing positive y and a positive x. And it's really just a guess. I know it's not going to be pi over 4 because at pi over 4, if you divide √2 over 2 and √2 over 2, you will get 1. Those are the same values. So I know it's not pi over 4. It's going to be one of the other two. So I'm just going to guess, is my angle pi over 6? Okay, and then I test that. If pi over 6 is correct, that means sine over cosine, 1/2 divided by √3 over 2 is going to equal, does that equal √3 over 3? So I'm going to work that out. 1/2 times, if you divide by √3 over 2, you multiply by 2 over √3. And let's see, the 2's cancel, leaving us with 1 over √3. Which doesn't look the same, right? Doesn't look the same, but this √3 over 3 is rationalized. So let's test this. If I multiply top and bottom by √3 over √3, you actually do get 1 times square root of 3. Square root of 3 times square root of 3 is 3, and you do get the same thing. So that was right, which means, yes, pi over 6 is the correct angle, or you could say 30 degrees. Either one is fine. Since I did not specify to answer in degrees or radians, just know that if it's a multiple choice question, I probably will give you the radian answer. So be comfortable with your radians. Let's see, moving on to number 35, the inverse secant of -2. the inverse secant of negative 2. When I think secant, I think cosine. It's a lot easier to think in terms of cosine. So I'm going to think of this as, this is, if you have the inverse secant of negative 2, that's the same thing as saying secant of some angle equals negative 2. And if secant is equal to negative 2, that means cosine, because cosine and secant are reciprocals, cosine is negative 1/2. So I'm going to find the angle where cosine is negative 1/2. Now your restriction for cosine and secant, the inverse cosine and inverse secant, is you answer on the top half of the circle. So I need to find the angle on the top half of the circle whereby cosine is negative 1/2. Remember, cosine is your x-coordinate. So I need an x-coordinate of negative 1/2. That happens right here. So your answer for 35 is going to be 2 pi over 3. Or if you want to answer in degrees, that would be 120 degrees. And again, it's very important that you fill in your circle correctly. I'm not going to give you a unit circle to look at for the test. You have to use the one that you fill in. Okay, good? You're good? All right, let's try 36. Let me go back and copy my circle. I'm going to need that. That is not at all what I wanted to do. Copy. Paste. There we go. All right, inverse cosecant. Well, cosecant and sine are very closely related. If cosecant of some angle is the square root of 2, that means sine of the angle is the reciprocal of that, which will be 1 over root 2. And your restriction for cosecant is the same as your restriction for inverse sine. So we will be answering on the right half of the circle. And let's see, sine is 1 over root 2. Well, it's not written like that on our unit circle, but if you rationalize that, if you multiply by root 2 over root 2, 1 times root 2 and root 2 times root 2 is 2. We're looking for the place where my y-coordinate is root 2 over 2. That happens right here. So our answer is pi over 4, or 45 degrees if you want to answer in degrees. You're good? You're good? All right, inverse cotangent. Now this is the one that trips me up a little bit, because cosecant and sine are reciprocals and they use the same part of the circle. Secant and cosine are reciprocals. They use the same part of the circle. However, cotangent, you would think it would use the same as tangent, but actually it does not. Cotangent, your restriction, is the top half of the circle. And there is a reason for that, and I could spend some time showing you that reason, but it's one of those things where, in all honesty, it'd probably just be better for you to accept that fact. It has to do with the graph of cotangent and where its first period lies on the x-axis. But just know that cotangent we answer on the top half of the circle, and I'm looking for the angle where cotangent is negative square root of 3. Now, well, just like with tangent, I know that I'm going to need to do some guessing and checking. If cotangent is negative, remember cotangent is cosine over sine. Y'all remember that? Cosine over sine. So I'm dividing my x and y's and I need a negative, which means if I'm on the top half of the circle, we need to be looking in the second quadrant, because if I divide those, I will get a negative answer, and we just have to guess. I'm going to go ahead and eliminate my 135, or 3 pi over 4, because if you divide those, you'll get 1, or negative 1. So I'm going to guess one of these other two, and I guess I'll start with 5 pi over 6. So I'm going to guess, is 5 pi over 6 correct? And the way I'll test that is I'll simply do cosine over sine. And if I guess, you know what, I'm going to guess, let's see, I wish I had done this first. I'm going to guess 2 pi over 3. Is that okay? If I guess 2 pi over 3 and I did cosine over sine, that would be, let's see, let's test that. Testing 2 pi over 3. Cosine is negative 1/2 divided by sine, which is root 3 over 2. And if you divide those, that'd be negative 1/2 times 2 over root 3, which is negative 1 over root 3. That does not look the same, but let's rationalize just to make sure. And if you rationalize that, negative 1 times root 3 times root 3 is 3, and that's not the same. I tried 2 pi over 3, and that ended up not working, so poop on that. That's not right, so we'll just scratch that out, which means my next angle I'm going to test is 5 pi over 6, so maybe I should have stuck with my first guess anyway. Oh well. So I'll test 5 pi over 6, and I'm 99% sure it's going to work, but let's test it just to make sure. So cosine, which is negative root 3 over 2, divided by 1/2 is the same as times 2 over 1. We'll see the 2's cancel, and you are left with simply negative root 3, which is what we want. So we know that 5 pi over 6 is correct, or if you want, you can answer in degrees. Okay, good, 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 good. All right, the very last one over here, number 38, the arc cosine of root 2 over 2. Arc cosine of root 2 over 2. That one's not too bad because cosine, you only need to look at the x-coordinate, and you are looking on the top half of the circle. Let's see, so inverse cosine, I need x to be root 2 over 2, happens right here. So the answer to this one is pi over 4, or if you want to answer in degrees, 45 degrees. If you do answer in degrees, make sure you put the degree symbol. That's a unit. It's like feet or miles or something like that. Radians, it's one of those weird things. You actually, if you don't write a unit for an angle measure, it's understood to be radians. So you don't have to actually write the word radians, but if you wanted to, you could. It wouldn't be wrong. Let's see. There were a couple of other problems. How many more are there? 39, 40, 41. That's it. All right, so last 3 problems. The sine of the inverse cosine of 1/2. Well, we're actually going to start on the inside, which makes sense. Don't we usually start on the inside when we're doing math? So we're going to start on the inside, and we're only going to look at the inverse cosine of 1/2. We're going to answer that part first. So what I see here, the inverse cosine of 1/2, I recognize that if I look only at the inside here, I look only at the inside, this piece right here is saying that cosine of some angle is equal to 1/2, and that's on the unit circle. All right, so I'm sorry, I paused it and had to come back. Now I forgot where I was. We were working on the inside, finding the angle where cosine is 1/2. This is a nice problem because that is actually on the unit circle. There are places where cosine is 1/2 on the unit circle. Remember that for inverse cosine, you do answer on the top half of the circle, and the inverse cosine of 1/2, we'll see cosine, that's your x-coordinate, that happens right here at 60 degrees or pi over 3. So all of this stuff right here, inverse cosine of 1/2, that is equal to pi over 6, or I'm sorry, pi over 3. So the inverse cosine of 1/2 is pi over 3. That's the angle. And then I need to find the sine of pi over 3. And the sine of pi over 3 means find the y-coordinate at pi over 3, which is root 3 over 2. And that would be your final answer for number 39. I'm going to come back in a little bit and do this a different way, a way that I think may actually be a little bit easier, but I'll let you decide. Let's see, number 40, the cosine of the inverse sine of negative 1/3. Okay, this one we run into a problem. Jeez, I always forget it doesn't swap to the arrow. There we go. The inverse sine, or the arc sine, that's the exact same thing. Don't let the notation scare you. The arc sine of negative 1/3 means you want to find where on the unit circle our y-coordinate is negative 1/3, and that never happens. We have some square root of 3's, but we don't just have a 1/3. So since this is not on the unit circle, I'm not going to be able to use this. So we'll shrink this up. Disappeared. So we shrink that up. We've got to come up with a different way to answer this because this is not on the unit circle. Let's see. What I will do is I'm thinking, okay, this is saying that sine of some angle is negative 1/3. I know that inverse cosine, if you answer, or I'm sorry, inverse sine, if you answer an arc sine question, you have to be looking on the right side of the circle. So if sine is negative, I have to be in the 3rd quadrant, right? I mean 4th quadrant, not 3rd. I have to be in the 4th quadrant. So what I'm going to do, this problem, to solve this, we're actually going to go back to drawing triangles like we did on some other sections. And this time, I'm going to draw my triangle into the 4th quadrant. That's not what I want. Here we go. Draw my triangle going into the 4th quadrant. And remember, when you draw the triangle, you go into the quadrant from the origin, into the quadrant, and then back to the x-axis. And there's my right triangle. There's my right angle. Your angle theta is also measured back to the x-axis. And sine tells you opposite over hypotenuse. So I know my opposite side is going to be 1, my hypotenuse is 3, but I went down. If you go right and down, moving down is a negative movement, so that's a negative 1 over 3. And then I need to find the adjacent side, and I'll do that with the Pythagorean theorem. A squared plus negative 1 squared equals 3 squared. A squared plus 1 equals 9. A is going to be the square root of 8. 8 is 4 times 2, and then the square root of 8 cleans up to 2 times the square root of 2. So that is my A. I am moving to the right, so if I move right, that would be a positive distance, so I'm going to leave it as positive 2 root 2. And then what I've got to do is I need to find the cosine, and all of that, this triangle represents the angle where sine is negative 1/3. So I need to find cosine of this angle right here. So cosine is adjacent over hypotenuse. Adjacent in my triangle is 2 root 3. Hypotenuse is 3. There's your answer. Okay, good? Okay, good. And you know what? Even if this were on the unit circle, if it was on the unit circle, if it be on the unit circle, you can still do triangles. And that's actually what I'm going to do. I'm going to go back to number 39. And even though this technique works just fine using the unit circle, I could also draw a triangle and solve this on a triangle in case you think that's easier. I personally think it is. So let's see. I'm looking at the inside. Cosine is equal to 1/2. I do know that inverse cosine has to be on the top half of the circle. And if cosine is positive, I have to be looking in the first quadrant. So I'm going to draw a triangle going into the first quadrant. Going into the first quadrant. Go back to the x-axis. Let's label this triangle. Here's my right angle. Here's my angle theta. And we know that cosine is adjacent over hypotenuse. And if I'm in the first quadrant, everything's positive. I will get the other side by doing Pythagorean theorem. 1 squared plus b squared equals 2 squared. B squared is equal to 4 minus 1, which is 3. And you get b to be the square root of 3. And then we need the sine of this angle. And the sine of theta in that triangle is opposite root 3 over the hypotenuse 2, which is the same thing. You get the same thing either way. So if it's on the unit circle, you can base off the unit circle, or even if it is on the unit circle, you could still draw the triangle to match that situation. So there's 39 and 40. Okay, number 41, tangent of the inverse secant. Okay, inverse secant is like cosine. We use the top half of the circle. There is no place on the unit circle where we're going to get a 5, so I know I'm not going to be able to find this on the unit circle. We have to draw circles, or triangles. Let's see, if secant is positive, this is saying secant of some angle is 5, which is the same thing as saying cosine of the angle is 1/5. You do the reciprocal. And I am drawing in the first quadrant because cosine is positive, secant is positive in the first quadrant. So I'm going to draw a triangle into the first quadrant. So let's draw my triangle. Oh geez, what just happened there? I don't know. We'll pretend that's not there. Let's see, right angle, theta. And cosine is adjacent, so my adjacent is 1. My hypotenuse is 5. I'll do Pythagorean theorem to get my third side. 1 squared plus b squared is equal to 5 squared. 25 minus 1, b squared is 24. Excuse me. B equals root 24. 24 is 4 times 6, and the square root of 4 is 2, so that cleans up to 2 square root 6 for b. I am in the first quadrant, so everything is going to be positive. And now I need the tangent of the angle represented by that. So the tangent of that angle is opposite over adjacent, which is 2 square root of 6 all over 1, or just 2 root 6. So that would be your answer to number 41. And I believe that is everything on the review. It is! So guess what time it is? Triangle Man time. Ooh, Triangle Man has an open head wound there. He's probably not too happy. We'll just go, yeah, it's not a very happy Triangle Man. There we go. Triangle Man. He's got an open head wound. He's probably bleeding. Let's draw some blood. Oh, now he looks like Volcano Man. Or Punk Man. I'm not sure. So there's our Triangle Man. Let's see. And we know we can make him... Now, watch this. Okay, enough wasting time.